right, I think. We'll see. We'll see. Stuff happening. We working it? Alright, we working it. I don't know how loud the music is though. Alright, welcome to a day of programming. We're going to be, well, programming. Welcome to the future. Welcome to the Matrix. Welcome to the red pill, blue pill. Are you going to be left behind by technology, or are you going to use AI to keep up? And that's the big question. We're going to warm up a little bit. Ah, my coffee is gone. We're going to warm up a little bit, but I'm going to make a cup of coffee. So, in a moment, we'll get going. I'll let the process start over. Get people joined in. Normally it takes some lag before people start joining in, but ooh, I do need some coffee. So we're gonna warm up with a game. A pretty cool little game. Let me show you the game. This guy. We're gonna be a little robot. This guy right here. This is us right here. And we gotta collect hay in the piggy bank. We're going to be using Python scripts to program and basically get it going to automate the process. The game is called The Farmer Was Replaced. So I'm looking at you farmers too. It's about that time. We'll have to be really farming, programming nomads soon. So we'll be using this, playing this, getting a little bit of a warm-up with Python. I'm gonna kind of let the stream go for a moment. I'm gonna make a coffee real quick. My cat is in the way. Here he is. My baby boy. My little shy Joe. Meow. No, he's so cute. He just sleeps in my lap all day. Alright, I'm gonna let you chill on the chair. I'm gonna make a cup of coffee. I'll be right back. This game was also recommended. Why do I have two microphones right now? What are you? A more sensitive version of my microphone? Okay, great. Oh, because I switched sources. I'm still working on this whole going back and forth between things. Anyway, this was recommended to me by a viewer. Leaving me a comment. So leave comments if you have any ideas for games. If you know any games that require programming and you're not sure how to play them, I will learn how to do it. I would teach you how to program that game or play that game through programming, right? But this was, let me show you. Pretty chill. I do like the atmosphere here. This was brought to my attention by Mr. Bruce Baldwin. The game, The Farmer Was Replaced. Or Farmer Gets Replaced? Hold on. Was replaced or gets replaced? Hold on, now I'm confused. Was replaced. Was replaced. The farmer was replaced. So he gave me the idea. He directed me towards this game. Oh, hello. So full credit to Mr. Bruce Baldwin, 3630. Thanks for the hint. But if you do have any games you like that are based on programming or complex, I love puzzle games, as it goes. If you like programming, you like puzzles, in a way. So, do let me know in comments or chat. Give me that game. Let's play it together, and I'll teach you how to work it. But until then, let me grab my coffee. There we go. And towards the end of the video, I wanted to go into detail on this little AI agent that I've been playing with. Where is it? Where are you? Aki? Oh, you're all the way in the background. Right there. Now, typically, AI based on your computer, on your device, right? On your local computer, it's not connected to the internet. You don't have any way for it to connect. A good case is like the Ollama server that I recommend everyone have on their computer at this point. Even if you have a basic graphics card, you can still run a pretty decent base model on your system. There's a case scenario to know that the size of that model will bear certain amounts of knowledge within it. And the biggest thing I want to really point out is AI isn't intelligent. Contradictory to what it says in the name, right? Artificial intelligence. You can really think of AI, these AI models, as a type of knowledge base, a vectorized data set. Just the way we look at images in PNG pixel-based format, and then we can convert that pixel-based image to vector equations. We save a ton of space in that process, and the image becomes much more efficient to load. So having icons, images created in vector space are actually super efficient, super small, and a computer calculates the equation that makes the image pop out. The counteracting to this is an image in PNG. A PNG image has to literally keep track of every single pixel and what color it is throughout the whole image. The higher the resolution, the harder or larger the file to maintain that image. So now transcribe that whole idea into knowledge. We have the internet full of databases and MySQL, all kinds of set of information hosted online. And what these AI do is they will take all the info that would be our pixels in this digital knowledge world. It takes all that info and then compresses it into a vector, into a type of equation, into a type of system where that knowledge can now be reactivated using equations, using mathematics, which is again more efficient based on the PNG to SVG format of images. And that's basically what an AI is. It's just all the knowledge, basically all the knowledge on the net or wherever was trained on, all of that knowledge compressed into a couple of different sizes. There's a 1 gigabyte version, a 1B model, 3B models or 3.5B models, 7B models, and so forth. The general rule of thumb is for every gigabyte of space in your virtual graphics card RAM, that'll give you about a B in that space of the AI, because the AI has to be loaded on as a model onto your graphics card virtual. And then from there you can use it, ask it questions. So anyone can really run an AI locally. The question is, how much information does that particular model have on your local machine? And the answer is really based on the size of that model. Now, it doesn't mean that the larger the model, the more intelligent it is. The bigger the data set it has, sure, but then because of so much info, this is kind of like a hardware issue. Thinking of processors and the cache, right? There's always a fight between efficiency and processing and having just small amounts of cache so that information can move quick and accurately, versus overburdening a lot of information and just causing too much data, too much info to parse, and it gets slower, it maybe becomes inaccurate, inefficient. So the bigger the model, yes, it does have a larger data set of information, but it does essentially still have a bottleneck on so much info trying to flush through for a single answer. It can make mistakes, it can hallucinate, it can use the wrong data set information back and forth, and there's a decent argument between whether a large model or a small model is more efficient. My argument is use a small model, give it access to the internet, and then let it research, because it has efficiency in that form. It can research and pull information on the spot and then answer the question specifically. So instead of having to like load up with 50 graphics card or like PewDiePie load up, we might actually watch that video. I've been wanting to watch that video live. But PewDiePie created his own little $20,000 graphics card rig for AI processing. And the question is that necessary? Even he got to a point where he noticed the bottleneck of information. And his counsel, which we'll go into, his counsel was too smart, and they tried to collude against him. Which is crazy for an AI, to be honest. It was too smart. So he lowered the intelligence of these AI, used a smaller model, and then they were able to complete tasks more efficiently without having to question, overthink. Overthinking is the key then, because it's a human consistency too. I overthink all the time. So in a way, we're really looking at that perspective. Is more information better? Or is it just clutter? And do we base our AI on its knowledge base that exists within the model, or within the tools that it can use to discover that knowledge, even if it didn't understand it or know it in the beginning? And I believe it's all about the tools. PewDiePie also mentioned this about tools as well. And I'm pretty sure in this case scenario, having an AI with tools, this is why I'm practicing a lot on these sort of, I got a little web llama here, where we'll go into detail in the pieces, but I'm using DuckDuckGo through a WebDriver, through a Chrome WebDriver to surpass the CAPTCHAs, basically to pretend it's a real browser. So it uses the WebDriver from Chrome, opens up a window, accesses DuckDuckGo, runs a quick query, grabs the HTML, and then brings it back to the actual thing. If I run it from here, let's say, what are the top 10 news headlines? Sometimes it's weird. It's a weird one. I'm trying to really balance the simplicity of the ask with the tools that it has. So it's actively now searching the internet using the search internet function, which is right here. Oh no. And I'm also running this on top of everything else. Remember, it takes up graphics card. I really hope this doesn't crash everything that I'm doing right now. That's a big problem. Hold on, let me check my graphics memory. 99%. Oh, that's nice. Perfect. So it's going to be slower because I am recording, playing a game in the background, and also activating my AI to do a search for me and do processing on it. All of those things require graphics processing, unfortunately. But it would normally do it pretty quick. You know, it goes online, grabs the details, comes back, tells me what happens. But it would normally open up a little window, go through a browser search on DuckDuckGo, grab the info, bring it back, and then report, hey, these are the top 10. I'm trying to get it to be really accurate with the details, provide sources, and all those extra little cherry on top features. So I can also go back and go into more details on the responses that it's getting. Oh, but the farmer was replaced as taking up a lot of space. And my OBS is taking... Okay, so the game is taking up 30% of my graphics. The OBS is taking 20% of my graphics. My performance right now is to a crawl. So I probably need to do... My GPU is at 100. Well, okay. The memory is at like 6.8 gigs. That's fine. That's alright. But the utilization is huge. Ah, there we go. But see, this is the problem too. It uses its own knowledge, and I'm not even sure if I should downgrade the AI I'm using. Even though I told it to search top news headlines. There's this weird... This is why AI is really not that great. In retrospect. It's using its already trained data. And even though I'm saying... What are you doing here? It's not taking the instructions seriously. That's the problem that I'm having with these. I have given it, right, the date. WebLlama. Wait, is this an older version? No, it doesn't have the date in here. Hold on. Only a single instance of the following. I do have to modify the actual query too. I didn't, because I have multiple versions. I'm playing with the different responses. This one should have a date time. 2 descriptions. I gave it the ability to execute code, but it kept trying to execute code when it already had an existing search internet function available for it. Which was weird, because why not just search it? Why do you keep trying to recreate the code? Yeah, okay, so here's the date now case. So the system prompt is what you give the AI to basically give it instructions on how to react. Right, so what do you do when this case scenario happens? How do you prioritize one thing over another? At some point, it was doing multiple actions with conflicts with the Python parser. I only wanted to do one action, one input, and it kept doing action, input, thought, action, input, thought under one reply. And then my code's like, alright, which action am I doing? You know, I can obviously optimize it a bit and have like an array of tasks to be processed, but trying to keep it as simple as possible. But this time around, it actually didn't use the internet because it didn't actually involve a URL. See, it's using the direct reference of parameter 1 instead of putting in URL for that particular case, because the parameter for search internet is query URL. Yeah. There's just a lot to go through to really dive deep into the actual AI things. But this is kind of the idea, is creating tools for your AI. Right now I've been playing around with it. I've done plenty of like successful case scenarios. I think one of my older copies did pretty well, but I also loaded it up with instructions, so it was confused on how to work with the information. So I try to optimize the instructions to be much simpler. and then try to simplify the system prompt while still giving it enough information to effectively proceed with the tools given and with the query asked. Now, all in all, this is just using Ollama in the background. Ollama server is running. I'm connecting to it through its typical API access point. I'm using a particular model, Mistral latest, and then everything else is basically just a continuous loop until I say bye, and it processes each query through that Ollama server, which then makes judgment calls based on, hey, if the action that you find in the response from the AI is search internet, then run the search internet with the query it's asking for, and so on and so forth. So that's the overall loop. It's kind of like you're programming a program to program. Does that make sense? Does that make sense? Anyway, we've already dropped way too far into the rabbit hole of AI. I might go back into it later, maybe do a little bit of modification so you can see how it works, but for now, what we want to do is warm up with some games. Just a little bit of gameage. Gamerize. Where am I? Oh yeah, I have to make this go pop up, right? Where are you at? Where's my game? Oh, yeah, there we go. Okay, so let's play with Python. We're just learning basic Python. We're going to be controlling this drone to basically farm for us, get as much monies, lots of monies. No, having a mustache sucks. Everything catches on the mustache. Everything. Coffee, food. I'm almost ready to cut it off. Almost ready to cut it off. Anyway, we continue, right? Okay. So here's how this works, right? We're looking at some built-in functions that we're basically controlling our little drone over here with. I've got a simple harvest right now. And basically, we continue on forever. But during this forever loop, we check a couple of things. First, if we can harvest this particular plant, this grass. And if we can, we harvest it. And I've added in a little bit of a oomph to the factor here by changing the hat color each time it harvests. And if it doesn't, actually, maybe I'll do an elif or else and change it if it doesn't harvest, like so. So I could tell when it harvests, when it didn't. Oh, well, loop is slow enough that we don't have to worry about the else. So I'll keep that back over here. There we go. So here's kind of a running thesis on loops, right? We're working with basically controlling objects during a looping process. First, what is this? What are you? Minimize? Oh. Oh. Ooh. I wish I had a title. Okay, so we plant. General info, we'll keep that here. This is for planting. This is for expanding. Aha, movement. So this is the next thing we gotta work on. So as our little dude over here is moving around, right? He is activating the if statement and checking if he can harvest. If he can't, it automatically runs the change hat to gray. If he can, he harvests and then changes hat. Now there's kind of an adjustment that this game does make for infinite loops, and it slows down the loop so it doesn't basically over-process. Our goal then is to collect hay. You can see my hay in the top left corner going up right there. I farmed 1,000 hay. Nice. But there is a catch, because if we do it too quickly, aka if I just... Oh, can I do comments? No? Okay. Not globally. If I comment these out and I just do harvest, Oh, the hat messes things up, technically. This. The problem with this is we don't let the grass grow quick enough for us to harvest. So we're actually not collecting anything. So there's a timing period we have to abide by. Right? This is the only issue that I've run into so far. Which then basically goes into hey, if we can harvest, then let's harvest. And it checks to see if we can harvest before we actually run it. Now, the other catch here is that I can just change hat color that we just saw. And it gives it enough time to regrow. Because of the change of hat, the extra function in here slows down the processing, giving us that extra random coincidental sense of, hey, we can just basically keep doing this. Workaround, call it a hack, but does it really work? It does in this case. If you look at the actual growth, it's coincidental that we're matching the speed of the growth. I mean, the growth on this goes to 100% pretty quick. But the most effective way in any programming is to check if you can do something before you do it. And in this case, it's to check if we can harvest before we actually do the harvesting. Now we can see we're kind of faster. As soon as it hits 100% on the growth, we take it down. And it looks like it's growing at 0.5 seconds timeline. Okay, we've got the idea, right? We're kind of using code to control this little drone. What is the point of this? Well, we get some trees. We have hats, bunch of hats. We have expansions, which means we need wood now. We have to planting. I had that, right? Did I unlock it? Yes. Yes. Plant entities, carrots, entities, bush. Okay, so I currently have entities, bush. Call clear to reset the farm to all grass and reset drone. So grass grows by default. Looks like what we're going to want to do, probably to get that wood in our harvest. First, let's just give it a movement, right? It's kind of stuck in this little section here. So we got to move north, move south. A couple of easy ways to do this is just to alternate, keeping in mind what our current space is. Which would be in an array base. So using arrays, I can give it, well, if I keep going, let's say move north. As a simple extraction here. Oh, it actually loops back down. That makes it too easy. That makes it way too easy. You should have to change back to south once you get to the top. Alright, well, I guess that was pretty straightforward. I was going to create a map of this particular set of space, and then when we get to the end of that map, I was just going to reverse to south. But I guess that's pretty straightforward. Alright, so that's that. What's next here? We can plant entities.bush. So, can I check if grass? Plant entity bush. Grass is nice because it grows automatically. All the plants have to be planted with plant. The only plant you can plant right now is a bush. You can press type plant function like this. Alright, so let's kind of create a nice system of things to do. Alright. So action equals plant. Let's do plant right there. Other actions would be harvest. In fact, we should probably make an array of these possible actions we can do just to organize ourselves a bit. So we got plant, we've got harvest, and then we're going to have current action equals 0, which will automatically give this scenario to happen. So if can have harvest and current action equals 0, we're going to go ahead and harvest. Cause a runtime error. Oh, that's my first error. Cool. Wait, do I not have arrays? Are you telling me I don't have arrays unlocked or something? Must be unlocked before this can be used. No, I want to optimize. All right, whatever. Let's just do current action 0 for now. I think this should be enough. Wait, what? I can't use variables either? Hold on. What are you trying to tell me here? I've got a while loop. Set speed, get time, x, y, coordinates. Alright, fine. Simulate. What are you actually giving me here? Importing. Ooh, fun. But what? 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 How can I not be given the ability to create a variable? This is like Basics 101, mate. Oh, you son of a... I need to make bushes first. Alright. You know what? Fine. I'll play the game. I'll play the game. We are playing the game after all. So let's just do this. Since it wants us to basically go at it. Let's do... plant. This is just basics. Entities dot bush. Let's just plant stuff. So we're gonna plant, and if can harvest, it's going to harvest. Otherwise, it can just plant. There we go. So now it's just gonna wait for the bush to harvest, and then grab it, and then plant a new one. Oh my god, this is so silly. This is so silly. Where's my variables at, man? I'm getting... Okay, so now I can unlock something, right? Really? One bush is one wood? Also, if you do know any other games that require programming, please send them my way. I'm collecting every single game that has this kind of concept to it in programming. Arithmetic? Really? You're gonna have to make me unlock math? Printing? Oh, debugging. Yeah, alright. Carrots to unlock variables? Whatever. Oh wow, we can do math now, guys. Yay, mayo. Cool. Okay, keep that up here in our arsenal of stuff. This was general info. This was expanding. Let's throw these off to the side here. Planting, easy. $50. Oh, drone can see what's under it? The drone can see... Oh, this is where it can figure out... Oh, wait, hold on. What? Plant entities push. If get position and number items... Items that would... Okay, so it can identify the block underneath it. Okay, that's useful. And then I want variables. Oh, carrots. Oh no, carrots. Can I expand? Oh, yes, I can. Expansion! Yes! Okay, alright. Well, now we gotta expand our little loop, don't we? So... Case scenario. If there's nothing to plant, we want to go to the next and plant. And we just want to keep moving to plant and harvest. So, if can harvest, harvest. But else if we can see underneath us. So get item, get entity type. Was that the thing? Senses. Get entity type equals entities.push. Okay. So get entity type entities.grass. So if it's grass, we're going to plant entities.push. If it's not can harvest and it's not grass to plant, then else we're going to move east. Get entity type doesn't take any argument. Oh, you have to set it equal to. Hold on, how did it work? Yeah, you have to set it equal to. Okay, it doesn't take arguments to check. You just get the entity and ask it if it's going to be a bush. I think it's a bad order of operation. It's not perfect. So if can harvest, harvest. It's kind of weird. It's kind of random right now. It's not really organized. But you know what? It's not horrible. I mean, it's not completely inefficient. Why didn't it say harvesting? Can't harvest. Harvest the grass too, man. See, it's moving up there. Why isn't it? This is where an actual grid would be good. Actually creating a grid of the current size. Because it went over this. Why didn't it do anything here? This is where you have to work on the logic. It went through all the middle ones. Okay, I think I have an idea. So we can move LF here to harvest, because primarily we want no grass. So if we see grass, we always want to plant bushes. But if we can harvest, and can harvest. Okay, hold on. Logic has to be first. If can harvest type equals bush. So we want to harvest entity type equals entities dot bush and can harvest. We're gonna harvest it. We don't really need to care about the grass at the moment. So we're really specifying the logic here. Remove the LF from the front. So how do I explain this, right? Else and if statements really do work on a linear fashion. The first thing is always going to get checked. If it runs, nothing else gets run. That's the main concept here. So when we're checking for the grass, this is the first primary idea. Hey, if you see grass, just make it bush. End of day, right? But this movement north, it should always move north. Okay, so if it finds a grass and changes it to a bush, then we check to see if it's a bush and can harvest it, then we harvest it. It's so loose at the moment, it's just going to move east consistently. I think it might improve it a little bit, but let's check. Okay. It's not horrible. Okay. But see, it missed that one. Why did you miss that one? Now you got it. Maybe my move north is a little too strong without having an if statement. If I plant, move north. If I harvest, move north. Otherwise, move east. Let's move north into the actual logic here. So let's plant and then move north. Let's harvest and then move north. Otherwise, we move east. Oh, and this is kind of in the way now. That's probably another issue. Aha! There we go. Yeah, it's organized! Kinda. Alright, that's fine. I'll accept that. Nice, it's gonna go layer by layer now. Ah, it's beautiful. Ah, it feels so good. Nice, nice, nice. Oh, but then it misses one. Oh no. It's always gonna be one bush that's not gonna be set up. ¿Por qué? Oh, that's fine. Oh. Alright, well. Not bad. Now we've got it organized to a T. What's next? Carrots. We have carrots. Senses. Oh yeah. Do a flip. Fancy. The none keyword is also unlocked now. None is a value that represents that there is no value. Basically, undefined, there's a lot of references to none within the branches of programming. Undefined, zero, NaN, not a number. There's a lot of different kind of logical annotations for none. This one seems to be just a no value return. Function that has no return statement will actually return none. So if we find a function, so if there's nothing on there, get entity type, which would make no sense because we have an entity always. It's either grass or bush. Grass is the default entity, so it should always return something. If you want to find out how many of a particular unlock you have, use the numUnlock function. Will return the number of speed upgrades you have. Oh. God, there's so many like pieces to go for. Okay, great. What's this one about? Expandu. Ah, so okay, this is now doing loops and ranges, which I've kind of went around that. I've technically applied a logic of range without actually applying a logic of range. And it's all based on the check logic. Now technically I can fix that one little bush that never gets planted as a one little grass never gets planted as a bush by making sure I go through each range all the way through. Oh dude, I can zoom out. Whoa. This is so cool though. I really like this game. This game's sick. So for iron range, get world size. Oh, look at that. Wouldn't that be like... So I've basically done the same thing without doing the same thing. I've created a immediate logic adjustment based on certain concepts. If you see grass, change it to bush. If you don't see grass, then you see bush. If bush harvestable, harvest bush. And then just keep moving east each time you go through a full line. Which okay, so what if I wanted to add another function? F of 0. Also keep in mind diversity of these sort of processes, right? We have the main function running consistently here. There's no secondary running yet. But I can create two functions. I'll save this one as F1. So then I should be able to run F1. Backwards. F1 has never been defined. What do you mean? Oh. So I guess it has been defined though. I guess that's just a totally different running loop. That's unfortunate. That's not how it works. Normally the main loop should call F1 so that you can essentially run still a main-based system, a main type beginning point. But I guess in this case I can kind of run different applications, different mains. Okay. Well, what if we do based on the for I in range of get world size? Let's see what print. Oh, we don't have a print, do we? Probably don't have a debug print. Nope, we don't have print yet. Wait, hold on. Nope, we don't have print yet. Unlock debug mode. Sure. Okay. Well, let's just... I can't really see this. Harvest, move north. Let's just do harvest. Yeah, harvest. And then move north. Let's explore. So then this case, world size is the Y, the up and down case scenario. Show hints. 1, move north until it wraps back. 2, move east. It's another world size. World size, world size. Do a flip, move north. Yeah, well, okay, but there should be a, like... In this case, it's 3 by 3. Fine. But there's no, like, get world width and get world height. Then you can specify the specifics of the size. But in this case, we're just kind of using... Sure, we're using 2 different variables to describe different size types. Where you're using a 2-dimensional loop to move across it. So move east here, but I mean the loop itself still stops at the end of this movement. Okay. Yeah, see, it'll basically stop and begin at the same place. Then we can basically run it with a... Wow. See, the thing about this is so robotic now. It's going to follow the same path. Which is fine. And it cleans it up well. But it doesn't have reactionary processes. It doesn't have as many logical reactions based on the current block. The one I had was essentially running based on the reactions of the current action. So if we had grass... So let's do that, yeah. This is going to be the harvest everything function. This is going to be the plant bush and harvest bush function. Let's kind of bring it back to the beginning. Oh no. Let's just do it from there. There we go. See? See? It like harvests and replants at the same time. So it really reacts... logic. Like in the case of logical adjustments, I like the active adjustments based on the current action. Versus this one's just robotic. Keep re-looping over and over. And just harvest everything blindly. Which can be a good reset. Like harvest everything function would just basically harvest all of it. Reset everything back to grass. And then we can go again with another custom function. Otherwise... The plant, bush, and harvest function identifies what's in the current block and acts accordingly. And if they're all kind of growing or there's nothing to harvest, then it goes to the next and then repeats the loop until there's nothing else. So, more logically customizable, inclined, and then more robotic. This is kind of the breach between, is your code robotic and just going through loops, acting on things that may not necessarily be necessary to do? That would be super robotic, doing things when you don't have to do it. Or is your code reactive to the current situation? And that's what if statements are for. Logical statements. Logical statements gives us the power to act to any adjustments that might be made on the current grid, for instance. That's why I like if statements a lot more than loops. These are so many loops right now. We've got a main while loop, and then we got the 3 range loop for 4, and then another loop for 4. Now, if you know computer science, I mean, in this case, it's like not too crazy because we don't have a big world, but you're getting this big O square situation where if you keep expanding this, you're gonna have a lot more loops being processed. And normally I shy away from too many loops. I like one big loop with logic, versus 3 loops stacked into each other or nested. It's just more efficient to change things based on reaction or a reactionary based adjustment versus just do this all the time forever, keep looping over and over until your battery dies. It's just so robotic. Alright, well, we've harvested a crap ton of wood, a crap ton of hay. Let's see what we can update next. Alright, let's get carrots. We got carrots. Watering. Oh. Ooh, trees. Big trees. Oh, we need carrots, though. Alright, so we don't have a carrot function yet. So let's harvest everything. Oh, look at that. They stack together. What? Do it again. Do it again. What did you do? How did you do that? Oh, nice. Alright, cool. We got fun. Can I rename these? Oh, can I? Yeah! Harvest. Wait. F0 was harvest all. Harvest all. All. Right? F1 was bush harvest. That's cool. I like this. Bush plant harvest. That's gonna be the logical loop we're going through here. Nice, nice, nice. Can I move it? Can I move it now? Can I move it now? Good. We'll use main as a kind of experimental place. Once I find a good function here, and I get the process for it, I'll go ahead and save it into its own function. That's what I like to do. I like to make a main space where I can just code out everything I want it to do. Once it works, I put it in a function, use it later for a subsystem. And in this case, we're trying to do a, well, basically the same thing as a bush harvest. So, but instead of bushes, we're doing, so if it's grass, we're gonna do bush, we're gonna plant carrots. And this is, ooh, I can expand this. Oh, I don't have function inputs yet. Because then I can just have one single bush, no, one single plant harvest function, and I can put in the function parameters, what it is I want to plant. And then I just run it with the parameters plugged in. I think we're getting there. I think we're getting to that point. Now we're doing carrot, carrot. In fact, let's kind of prepare this. Oh, yes, I have variables now. Okay. Plant type equals entities dot carrots. I'm gonna go ahead and remove these. Okay. Hard coding code. When to hard code, when to use variables. Very important. In this case, I would have to go through and change every little thing about this function. Every time I put in entities.bush, you saw me just now go into every place and replace it with entities.carrot. In any case scenario where you see there would be a need to expand a function's capabilities to more than one thing, use variables. So I'm going to do plant type here and plant type here. So now I don't have to go all the way back through all the code and basically change everything from entities.bush to entities.carrots. I just changed this one thing. Okay. And what? Doesn't exist. Oh, carrot. Is it single? What? Adult thing must be unlocked. I didn't unlock it. Hold on. Oh no! I have to get the carrots to action. You know what? I have to do this in a second. Hold on. Keep that in mind, though. We don't have variables yet. We don't have variables yet. We're gonna do the thing in a second. You look in the grass. Plant the carrot. Why aren't you planting the carrot? Entities.carrot. Plant entities.carrot. I swear I have carrots, right? I have carrots. Increase the yield. Right click for more information. I have carrot. Oh, wait. Oh, carrots need to be tilled. Okay. Now we got extra steps in between. Got it. So we have to till and then plant. You have to till the soil. This will change the ground to ground soil. Ground that soil. To till the soil is simply called till. Okay, fine. So then before we actually plant, we have to do a till. Aha, okay. I see. There we go. Next level stuff happening here. Oh, so it doesn't plant grass anymore. Interesting. Okay. We don't have to till anymore, and my dude's confused because it's looking for grass. If it's grass, we till and then plant. But we don't have grass anymore. So now we gotta double check with or grounds dot soil. We don't need to till. This is a bit of a stretch. Oh. I mean, that was unnecessary. Wait, so till reverses the till? So a till will change it from grass to till. Okay. Now we need to expand the functionality here. It's not so great. So, or ground dot soil. So let's say that it is, we gotta split the details here. So first we will till. If, we will till if the ground is grass. But if it's not grass, if grounds dot soil, we're going to plant the carrot. Okay. If get entity type equals carrot and can harvest. Okay, so the logic here is too straightforward. It's always going to be this location where it stops our logic if and else's from continuing. It's always going to be a ground soil, even when there's carrots in there. So we want to essentially do this at the very last case scenario. We want to adjust the order of this logical check. We want to only move north if this would work, but it still needs more. We're gonna be stuck on one line. We don't have a move east. Okay. So now we are always checking for ground soil. We have literally always ground soil, so we never actually move east. So maybe harvest move we have to check if plant ground soil plant. We kind of want to always kind of plant, but then again can harvest if get entity type equals carrots, can harvest. If, okay. Oh, and get entity type does not equal to entities.carrot. We will plant the carrot. But if it is equal to entities.carrot, then we can do the move east. Okay. There we go. Not bad. Not bad. So we have to adjust for multiple steps in between now. This is pretty cool. I like the logical kind of lifting we have to go through to basically set this up to work efficiently. Carrots, give me these variables, please. Thank you. Now I feel comfortable. I love variables. Don't make me nerd for that, but yes, I am nerd for saying that out loud. Variables make things much easier. So now, what I wanted to do was kind of simplify this. But then again, this is so specific to carrots. Maybe it works for like potatoes and everything else. So tilling sounds like it's a consistency here. Tilling farm stuff. So I can basically say, oh yeah, Plant harvest. Oh yeah, I can expand this now. I'll let the action kind of work itself for later, but for now I want to do plant type equals to entities.caret. I'm going to use plant type in the places that I'm using caret so I can simplify my changes later. Generalizing everything a little bit. Yeah, so everything's customized to carrots now. And I can change this to potatoes and it'll work for potatoes. And then I can change it to whatever the heck else I need to. But the logic still has to apply the same. The potatoes, the whatever else pieces I'm planting still have to contain the same tilling step, the same checking step, the harvest step, all that kind of stuff. If there's anything that changes between the process, like we don't have to till, or we have to till a specific way, or we have to harvest with a tractor or something else that has to adjust, then we kind of have a big issue, a slight issue, not too crazy big, but a decent issue with adjusting the logic to continue. Okay. Okay, so lists, 500 carrots, great. I can expand. The nice thing about this is my logic is not going to depend on the size of the actual environment. It's just going to do this automatically as we expand. I don't have to change world size. I don't have to adjust for changes in the sizing. All it does is just based on the reaction. Speed. Can I improve speed? Where's my speed for this? Set speed. Treasure chests? What the heck? Set world size, set execution speed, get time, print. I guess we can get debugs and prints now. That's good. Get time. Pumpkins. Pass time. Oh, we can count. Oh, we can simulate. Test faster and under reproducible conditions. How far does this rabbit hole go? 100 million bones? Majestic ancient dinosaur bones? What in the world are we digging ourselves into? Polyculture. Use companion planting to increase the yield. Can I get a secondary drone? Am I only stuck with one drone? Wait. Interesting. I didn't realize that. Tilling uses up grass and wood. So I gotta use resources to get resources. Okay. That's a new kind of adjustment here. Functions. Define functions. 40 carrots versus 500. I think we can keep this going. I wish we had more time though. More speed, I mean. Watering. I don't really need watering yet. They seem to be doing fine without water, and the speed of this is essentially alright. Fertilizer. Sunflowers. I don't understand what this treasure is. Pumpkins. Carrots. Pumpkins. Pumpkin. 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 Unlock. Automatically unlock things. Oh, interesting. Allows access to cost of things. Interesting. So then we can make a huge... Oh, we can then optimize what the best cost for profit value would be. Plant entities, trees. Pumpkin. Mazes. A maze with treasure in the middle. What? Harvest treasure? What? What? A top hat? Oh, I want that. Oh, whoa, 100 million treasure for this? 1 billion? That's expensive. Mega farm. More drones! 2,000. Alright. Cactus? Alright. Great. Oh, well, okay, speed of things, but see, the problem here is speed of the drone and the code. There it is. Ah, that's what I was looking for. Now it's getting to be like a beat. My loop went too fast! Wait, hold on, hold on, hold on. Move east. Why is it not moving east and or planting? Weird. Warning, didn't have the required items to plant. Oh, I'm out of resources. Okay. Alright. And here comes the next step. Now I gotta figure out how can I check my resources. Check my resources. Get speed, simulate, define, import, get costs, unlock. Can I check resources? First program getting started, break, comments, continue, if while, expand, grass hat, speed. Can harvest, change, harvest, dual flip, pet the piggy. Huh? Items, hay, wood, entities, ground. I'm gonna go to inventory. Obtain from bushes. You have 0. From more related plant entities, that bush clear. Break. Okay, so I need to find a way to check for current resources. So I can balance output and input. Variables, can harvest, expand to grass, do range flip. First program 1.0 is finally here. Merchable drones to maximize farming. Credit stats, loading backups. Okay. Built-in functions, can harvest, harvest, move, number of item. Find out how much of an item you currently have. Okay. Good. So, I guess this would be still within the same loop. It's kind of gonna get a little bit of, what's the word? Crowded in here. But last case scenario. Oh wait, hold on. Because if we are in the planting space, so we should be able to okay, so we can customize this. If number items of entities dot wait items dot wood, okay, dot hay and or we will have to do. I want to keep them balanced, right? I want to keep them essentially balanced upwards. Or would mean if one drops, the other one doesn't matter. We're still going to plant. So I'd say and, just so we can make both of them balanced out. Items dot wood is greater than, call it 100 as a stock. We should always have about 100 of each item before we can plant carrots. A minimum value for us to keep in mind. But if we don't, so elif, now we check individual parts. Items dot wood less than 100. Then we're going to plant. Technically bush or tree. We can bush. We should bush for now. Entities dot bush. We'll adjust the tree if necessary for later. Else if number items item dot items dot grass hey, nope, hey, less than 100. Then we're gonna plant. We're not gonna plant, are we? Hmm. We're really going into an interesting circle now. This might be a whole different sense of a check. This might just be a whole different sense of a process. This, okay, so let's not overcomplicate just carrots. Let's not overcomplicate carrots. Carrots is good. Carrots is chilling, working fine, but we might need to make another check above all the others where it relates to this particular case. If number items, because still carrots related, we're still working within the carrots branch of details. We need resources for carrots, so if number of items dot wood is less than 100, then we're gonna take the plant type and set it equal to entities dot bush. So we're gonna go into a bush harvest. Then we're gonna check for the next case. Else if number of items dot hay is less than 100, then we're gonna do a plant type equals entities dot grass. Now this whole set, all of this was carrots. Everything that had, I'm gonna move the hats over here. Everything in this whole set was carrots. So now we gotta do, hey, if our plant type is equal to entities dot carrots, we're gonna do this process. We're gonna start with carrots, but we gotta check our inventory. So there's our inventory check. So if we don't have enough for carrots, we're gonna expand to elif plant type is equal to entities dot bush. Now we do have bush plant and harvest. We have the logic for that. There it is. Opa, it's a little bit messy. Hold on. Adjusting. There we go. So now we can do that. This would be for wood. But then we have the harvest all, which was kind of more grass related. But hold on, what are you doing, carrot? If plant type equals carrot, you're giving me an error? Carrot. Let's see. There must be a colon at the beginning. Oh, right, this is an if statement. And also here. Let's check what we have so far. Okay, we're looking at carrot. We haven't checked items, entities bush, but we're moving east because everything is tilled. Get entity type equals entity grass. So we're looking for grass, but we're not finding grass. We're looking for bush, we're not finding bush. So then the next case is to basically take that and say, hey, elif get entity type ground. Can I do ground dot soil? Get entity type. We're gonna till it back to a grass, I think. Hey, leopard guy, what's up, man? The audio was funky. Fair enough. Well, we can do it in the future for sure. I'm doing some programming right now. Trying to do some farming with code. Farming with code. Thanks for joining. Um, so I have a loop going. We're moving east consistently. So I don't think entity type is gonna work here. How did I check for soil? Entity.grass. Wood. Plant type. Okay, elif ground.soil. So then we can check elif ground.soil. Okay, there we go. Oh. We're tilling. Oh no, I'm not even harvesting at this point. I'm just resetting it over and over. Okay. So if entity is grass, we're gonna plant bush. We might want to move this to harvest first, primarily. The logic here should be first harvest if possible. Else, get entity type and check why we can't harvest. If it's grass, we plant. Finally, if it's bush... Ingrid! Hello! Welcome! How goes it? Hi! Welcome in. Just doing some program farming. Fun stuff. Remember, that's not his real name. He is incognito on the internet. Okay. So I'm gonna check for entity type. If it's a bush, I can harvest it. So I will harvest and then move north. So harvest first, then find grass. If it's grass, I'm gonna plant a bush again. If it's a bush and can't... Wait, did I do it twice? Oh, there's two of these. I don't need two logics here. If ground.soil. Now the tilling is interesting. This would be like a reset. Let me check. I believe it's not... What's today? Today's Tuesday? Wednesday. I think we moved Wednesdays to Thursday. So I have him on Thursday. I think this was because he had like a morning meeting or something that had to be adjusted. So we moved the session on Thursday. And the other one is Saturday. So Thursday and Saturday is when I see Grant. But if you do want to switch it back, let us know. We can definitely do tomorrow if it's more comfortable. But we had, I think last week or the week before, something with a meeting that he had to attend in the morning at the same time, or 1 o'clock. Well, 1 o'clock for me PM is like 10 a.m. for you guys. Whatever the case is, we had to move it. But if you want to move it back, let Lorena know. She'll schedule that for us. But otherwise, right now, written in stone, not stone, but written down, it's Thursday. Okay. Oh, I think I'm breaking my brain right now with logic. It's gonna do this tilling. Okay. Throw pizza hit the screen. Oh no. Did you take over your auntie's device? That's not how it works, Grant. You can't just throw food at the screen. Oh. Oh. I think I'm kind of like burnt out though for the logic of this. So I'm being interfered. I don't want to till unless it's converting it back for bush. Since we're doing bush to get wood, that's interrupting the process. Oh, but then I can also, yeah. If plant type equals entities dot bush and rounds dot soil. So if it's both true, then we can till it to make it the correct value. Oh, it's still going. I guess soil would be regardless. How do I check for tilled soil? Grassland. Okay, is not. How about and is not grassland? Yeah, that was pretty fun, Grant. I did enjoy exploring the dinosaurs. That was fun. Not a valid expression. Grassland. Okay. So if plant type does not equal bush, how about that? If it's not equal bush, then... Okay. Stuck. So move east then. We should move east. It's stuck here. If ground dot soil. Okay, because of the ground soil. So really I would have to put this. Plant type is not bush. And then I should be able to do a till without having it interfere. Yep, kinda. Uh-oh. Expanding. It's getting there. Pulling out entities, that bush. So that should really go for the next other ones. So it's not oh? Stuck. Okay, so we got less than. Now we do grass. Oh gosh, now I gotta go through this. Alright, I think I'm burnt. I think my logic connectors in my brain have been fried. It's a good startup. Yeah, we'll continue this next time. Whew, but for now, I'm gonna save this. Call this out. Woosah a bit. Maybe check out my little... Oh, I don't even want to look at the AI stuff now. Holy crap. That was so much logic to consider. Anyway, that's it for now. I'll come back in the future. Make sure you like and subscribe. I'm burnt. I'm very much out.